In 1979, the Three Mile Island nuclear plant suffered the worst nuclear accident in American history. In 2024, Microsoft signed a 20-year deal to switch it back on to help power its AI. And then they renamed it the Crane Clean Energy Center, presumably so you wouldn't make the exact face you're making right now. It's the corporate equivalent of getting out of prison and going by your middle name. Here's the part nobody puts in the keynote. That deal isn't a weird one-off. It's the business plan. The polite little chat window on your screen, the weightless one, the one that says, "How can I help you today?" is the storefront for one of the most physically demanding industries on Earth. An industry that now shops for nuclear reactors the way you shop for a phone charger. The chatbot is the friendly receptionist. The actual company behind it is a power plant wearing a lanyard. This is the story of AI's hidden energy crisis. Who has the power? Who pays for it? And what cracks when the grid can't keep up? Spoiler, the answer to who pays is, with depressing regularity, you. We're going to keep it specific, mildly unhinged, and honest about the numbers. And we're going to put our sources on screen because we're about to make some big claims. The future is already loading. It just needs somewhere to plug in. A normal web search mostly finds a page that already exists. Cheap, boring, done. A generative model does something more theatrical. It thinks out loud, one token at a time, through billions of tiny calculations. By one widely cited Goldman Sachs estimate, a single ChatGPT-style answer can use roughly 10 times the electricity of a Google search. The companies insist it's less than that. Fine. Take your smaller, more flattering number and multiply it by 1 billion prompts a day. There are two energy stories inside AI, and everyone tells the wrong one. Training, building the model, is the spectacular part. Thousands of chips running flat out for weeks, drawing the power of a small town. That's the part that gets the press release. But inference, every answer, every image, every time you hit regenerate because the first one gave the dog 6 legs, runs forever, for everyone, all day. Training makes the headline. Inference makes the electric bill. So how big is this really? The International Energy Agency put global data center electricity use around 415 terawatt-hours in 2024, roughly what a mid-sized country burns in a year. An entire nation's worth of power, so a chatbot can open every email with, "I hope this message finds you well." In the United States, Lawrence Berkeley National Laboratory found data centers ate about 4.4% of all electricity in 2023, and projected that could roughly double, maybe triple by 2028. In energy planning terms, 2028 is roughly the day after tomorrow. Nobody agrees on the exact finish line. Everybody agrees on the direction, up and to the right, alarmingly. Now, people keep throwing around the word gigawatt, like we all know what that means. We do not. So, quick translation from physics into English. 1 gigawatt is about 1 billion watts, roughly the output of a full-size nuclear reactor, enough to power something like 750,000 American homes. For the cinema fans, in Back to the Future, Doc Brown needed 1.21 gigawatts to bend space and time. Several individual planned AI campuses are asking for more than that, each, and not to travel through time, to generate pictures of cats in little hats, continuously, forever. If you want to actually understand AI, stop watching the demos and follow the power cord. That's where the real fight is. So, if the cloud has a smokestack is the kind of sentence you want more of, subscribe. I promise the rest of this only gets weirder. Want to see the future early? Look at Ireland. In 2023, data centers consumed 21% of all the electricity in the entire country, more than every single urban home in Ireland combined. In 2015, that figure was 5%. Dublin effectively stopped approving new data center grid connections because a small green island had quietly turned into a server room that happens to have a flag. Ireland, famous for poets, pubs, and now, legally speaking, being a data center with a national anthem. Here's the awkward physics. AI scales like software, but the grid scales like concrete, steel, and paperwork. AI moves at the speed of light. The power grid moves at the speed of a county zoning board. When a company decides to build, it wants gigawatts now. But new transmission lines, transformers, and connections take years. And in many regions, there's a literal waiting list, the interconnection queue, measured not in weeks, but in calendar years. Software ships overnight. Substations attend 3 public hearings and then ship in 2031. And when the grid can't deliver fast enough, some companies just bring their own power plant. In Memphis, Elon Musk's xAI fired up its Colossus supercomputer using dozens of portable methane gas turbines, running for nearly a year, largely ahead of the proper air permits. The neighborhood next door, Boxtown, is a historically black community that already breathes some of the worst air in the state. The NAACP moved to sue. The cloud, it turns out, has a smokestack, and it is parked in someone's backyard. Now, every one of these companies has a beautiful climate pledge, and every one of them is quietly blowing through it. Google's own report showed its emissions up roughly 48% since 2020, driven, it admits, largely by AI and data centers. Microsoft's climbed too. The slogans still say carbon negative by 2030. That asterisk is doing the single heaviest lift in the entire tech industry. It should get its own gym membership. Which brings us back to nuclear, and not just 3 Mile Island. Amazon bought a data center wired directly to a Pennsylvania nuclear plant. Google and Meta are chasing reactors. Sam Altman is personally funding nuclear startups and betting on fusion because he has done the math on what's coming. The tech industry spent 20 years being far too cool for nuclear power, and then speed ran an entire national energy strategy in about 18 months. 20 years of treating nuclear like the weird kid at school, then sliding into its DMs at 2 a.m. because suddenly they need something only it can give them. Electricity is only half the appetite. All those chips run hot, and a lot of them are cooled with water. Your chatbot doesn't sweat. The building it lives in sweats for it, into a cooling tower the size of a parking garage. Researchers at UC Riverside estimated that a short series of AI prompts can quietly evaporate something like a small bottle of water through the cooling system. On its own, nothing. Across billions of conversations a day, in regions that are already running short of water, slightly less nothing. But the chips keep getting more efficient. Yes, they do. And it may not save us. It's an old, almost rude little pattern called Jevons paradox. Every time a technology gets cheaper to run, we run a great deal more of it. Make AI 10 times more efficient, and we don't use the same amount for 1/10 of the power. We use it 100 times as much. Congratulations! You've rediscovered economics, and the power meter is still spinning. So who pays for all the new wires and substations? Sometimes the tech company, sometimes the government via tax breaks, and sometimes, through your monthly utility rate, you. In Virginia, home to the world's densest cluster of data centers, the state's own watchdog warned that ordinary customers could end up subsidizing the build-out, and residents and regulators are now openly fighting about exactly that. You may already be a minor, unwilling, non-voting shareholder in a data center you are not allowed to visit. Now, the honest other side, the same technology causing this could also help fix it. AI is genuinely good at forecasting electricity demand, balancing messy renewable grids, optimizing cooling, and hunting for better battery chemistries. The machine eating the grid might also turn out to be one of the better tools for running it. Yes, the arsonist has, on paper, an absolutely stellar resume in firefighting. That's the optimistic ending. It is not automatic, it is not free, and it is absolutely not a reason to relax. For years, the AI bottleneck was data, then model size, then chips. The next bottleneck is gloriously unsexy. Transformers, substations, cooling water, and permits. There is, right now, a genuine global shortage of the large electrical transformers these projects need, lead times stretching to years. Nothing says science fiction future quite like being blocked by a heavy gray box most people have never heard of. The most advanced intelligence humanity has ever built is currently stuck in a shipping queue behind a transformer the size of a garden shed. So if you want to know where AI is really going, watch the boring stuff. The demos are the surface. The grid connection is the constraint. AI feels like a frictionless little conversation with the future, but the future sends an invoice for power, water, land, wires, and one freshly unretired nuclear reactor with a cheerful new name. So the next time an answer appears instantly on your screen, just remember what had to wake up behind it. The intelligence is digital. The appetite is extremely, expensively physical.